Exercise 2.31. In active example 2.3, the cable AB exerts a 900 Newton force on the top of the tower. Suppose that the attachment point B is moved in the horizontal direction farther from the tower, and assume that the magnitude of the force F the cable exerts on the top of the tower is proportional to the length of the cable. A. What is the distance from the tower to point B if magnitude of the force is 1000 newtons? B. Express the 1000 newtons force F in terms of components using the coordinate system shown. Alright, so this would be an exercise in which we're going to analyze this tower. We do not need any different information of example 2.3. I just took the figure for us to solve it. So as always, we're going to read it again, taking into account the information and write it all that we require down. All right. So right here we have that the cable AB exerts a 900 Newton force. So our AB, the magnitude, is going to be equal to 900 newtons. They are telling me a statement pretty important, which is the force is going to be proportional to the cable length. Right? This is pretty important. The second thing, they are asking for the distance. We're going to explain that in a second because I think that it's better for us to see it graphically. Right here we have our point A and our point B, right? A and B. At first, as you can see right here, we have 40 meters, and right here we have 80 meters, right? And finally, we have the magnitude of this cable, of the force of this cable, which is 900. Right? So we are playing right here with lengths and forces. The first thing that we must do is to find an equivalence between those two. So as you can see, what we have right here is a rectangle triangle, what we call a rectangle triangle. This is 40, this is 80, and this is an unknown, which is the hypotenuse. So I can find it that pretty easy by just applying the equation that I think it's pretty well known, which is that the hypotenuse is equal to the square root of one of the cathetus square plus the other square as well. Now the hypotenuse in this case is going to be equal to the square root of 80 square plus 40 square. It's equal to 89.4427 meters. Right? Now the force is proportional to the length. Right? So I can see or I can say that 900 newtons is perfectly equivalent to 89.4427 meters. Alright? Now, we are going to pretend that we are not longer applying a 900 force right here, but instead we're going to apply a 1000 newtons force. In that case, it is like pretty rational for us to move the B to another part, right? Which one? We don't know that yet. Maybe it's closer, maybe it's farther. Okay, the exercise told us, but as you can see right here, farther. Yeah, the exercise told us, but we can assume that we don't know that yet. So what we're going to do now is that we need a second triangle, which is the new one. Right here we have a force on 1000. Right here I have an 80 meters, and this is an unknown that I'm going to call K, for example. But I cannot use right here 1000 because 1000 is a force, 80 is a distance, as well as K, which is the first solution for the A part of the exercise. What is the distance from the tower to point B if the magnitude of the force is 1000? So we require this distance, which I'm going to call K. Once we have found this equivalence, I can say that this is going to be equal to 1000, which is the new force, divided by the new hypotenuse, which I'm going to call, I don't know, H2. Alright, now H2, if you solve this equation, is equal to 1000 times 89.4427 divided by 900. H2 is equal to, so right here I have the answer, times 1000 divided by 900. Okay, right here I have the distance is equal to 99.3807 meters. And that is what I'm going to use in this triangle, 99.3807. Now, K is going to be equal to the square root of 99.3807 square minus 80 square. And this is equal to, answer is 99, so right here I have this minus 80 square. Alright, so K is 58.9622. I always use I always use 4 significant digits after the comma. And we are talking about meters, and this is the first answer for the A part of the exercise. The A part of the exercise, sorry. Now, we have the distance, but the exercise in the B part is asking to express the 1000 Newton force in terms of components. So we have to change these and these into a force. So we're going to use the same equivalence as before. First, 900 is equivalent to 89.4427, right? Newtons and meters. Now I'm going to look for the F, in this case X value, using the value that we just get, 96.22. And I'm going to use as well the Fy for me to represent the force in the y direction, taking into account just the 80. Right? As you can see, for those of you who didn't understand what I just did, don't worry. No worries, because right here we have our equivalence that we used before. Now, we cannot use the distances for when we want to express a force component. If you want to express a component of force, you have to use the same kind of units, which is newtons in this case. So right here we have newtons, and right here we have meters. Is equivalent, and same as this. If you didn't get it, please stop the video and repeat it. No matter how many times you repeat it, the important thing is that you get it. But yeah, newtons, meters, equivalents, and right here I have our first equivalence. That is pretty much it. Now, using this, I can say that Fx is equal to 900 divided by 89.4427 multiplied by 58.9622. Sorry, 0.9622. All right. So this will be equal to 593.2958 newtons. And Fy is equal to the same thing but multiplied by 80. $804.9846 newtons. Alright, so that would be pretty much it, because right here we have our component in the x-axis and right here we have our component along the y-axis. What's left is to write down the information to know how to write it, and that would be all for the second part of the exercise. So 1000, which is the magnitude of the vector, well, RAV, but the magnitude. And now we're going to write down the components. Now the vector is going to be equal to 593.2958 along the I direction plus 804 plus 98.46 along the J direction. Now the summatory between these two evaluated to a second power, every single one of them, two of them, must be equal to 1000. So we're going to test that now. 593.2958 squared plus 804.9846 squared is equal to 1000. Right, so it's perfect. Do not worry about these numbers, because remember, for when I'm writing down these numbers, I am missing, or I'm not taking into account all the decimal numbers. So if I do it, which is not necessary, I would have a perfect 1000 right here, right? This is actually pretty good. That is why I always use just 4 significant digits after the comma, because I already know that this is pretty accurate. And that would be all, guys. Right here we have our second answer for the B part. This is the A part. And this is how this exercise could be solved.